So another question for the nth order differential equation is what is the general solution? You know that for since you have an nth order differential equation, you will find n different solution. And to write the general solution, you need to make sure that their Wronskian should not be 0. You know the Wronskian, you are writing the solutions, you are taking first derivative, second derivative until the n minus 1 derivative. And you need to take the determinant of that, and you need to make sure that this is not 0. And after that, if this is not 0, the linear combination of this f1 to fn will be the general solution of your differential equation. So let's do one example about Wronskian. Here you go. You saw that 1t e to the minus t, t times e to the minus t are the solutions of your differential equations, let's say. And this is the differential equation. And let's determine the Wronskian. And it says that verify that these are the solutions of this differential equation. So to be able to verify that, you know that if this is the solution, then once we plugged in this differential equation, it has to be 0. That's why we need to take the second derivative, third derivative, and fourth derivative, and we need to plug in this equation, and we need to make sure that this is 0. This is exactly what we are doing for each of it. So for f1 equals 1, here you go, we are taking the first derivative, which is 0, and all other derivatives are 0. If you plugged in here, 0, 0, 0, it will be 0. And for t, again, first derivative is 1, but all other derivatives will be 0, since there is no first derivative, so the sums of the zeros will be 0 again. For f3, it was e to the minus t given here. Don't forget that. This is our f3. We need to take first, second, third, and fourth derivative. Here you go. The first derivative, the negative is coming. The second derivative, since there is one more negative, it's positive. Third derivative, it will be negative. Fourth derivative, it will be positive. So we are writing inside the equation fourth derivative plus 2 times third derivative plus, what was that? Our equation. Fourth derivative 2 times third derivative plus second derivative, which is gonna be 0, yes. And f4 was t times e to the minus t. In here we need to take the derivatives, but since there are two terms, we are using the product rule here. So derivative of the first times the second plus first time times the derivative of second. Exactly what we did in here. This is the first derivative. After that, we need to take the derivative. Derivative of this one is just directly you can write by multiplying with negative. And for that one, again, we are using product rule. And if you write that out, second, third, and fourth, you can do that. And if you plugged in, you will see that this is going to be 0. Make sure that you try this one at home. And we verify that these are the solutions. If that's the question, you can do that easily. And for the Wronskian, we are writing the solutions. We are taking the first, second, and third derivative for each of it in here. And you know that how can you take the determinant of 4 by 4 or n by n matrix? What you need to do is, if you can turn this matrix into a triangular form, then the multiplication of the diagonal elements will be the determinant of your matrix. And this is exactly what we are doing. To make this matrix upper triangular, we need to make this function 0. And to do that, I can multiply the third row by, no, I don't have 1, and add them out. If you add third and fourth row, and this will be the new fourth row, and this is exactly what you will get. This will not change. This will be 0. And if you add these two, 3 minus t plus t, t's are gone, plus minus 2, there will be just 1, e to the minus t. Here you go. Then the determinant of this 4 by 4 matrix will be what? Just the multiplication of the diagonals. 1, 1, e to the minus t, e to the minus t, e to the minus 2t, which cannot be 0. So these are going to form the general solution for your differential equation.